All right, join me on page 270 in your science textbook. Just so you know, the picture on the screen right here is the scientific theory on plate tectonics and the shift from Pangea, or kind of one large continent, slowly into the world that we see today, where the continents slowly drifted apart. Okay. All right, join me on the top of page 270. What forces shape Earth? Many things change over time. Many changes happen quickly, but many other changes happen very slowly. Even Earth's surface has changed over time. Mountains rise only to be worn down by water, wind, and particles of rock. The ground is so firm it can support the tallest buildings with ease. However, the ground can suddenly shift, bringing those buildings down. Even something as large as the continent you live on has slowly moved to its present position. The idea that the position of huge continents can change over time might seem strange. Alfred Wegener was a German scientist who proposed a theory to explain changes in Earth's surface over long time periods. Like many other people, he noticed how closely Africa and South America would fit together if the two continents were pushed against each other. Wegener wondered if the other continents would fit in similar ways if they were moved together. In 1912, Wegener proposed a hypothesis of continental drift, the idea that a past supercontinent split apart into pieces which drifted over time to their present locations. Okay, on to page 271, continental drift. According to Wegener's hypothesis, Earth once had one single landmass or supercontinent. Wegener called this landmass Pangea, from the Greek words meaning all land. About 200 million years ago, Pangea split into two parts, which are called Laurasia and Gondwanaland. Later, these two landmasses broke apart to form North America, Eurasia, South America, Africa, Australia, and Antarctica. Over millions of years, these continents slowly drifted to their present locations. A geologist is a scientist who studies Earth's origin, history, structure, composition, and processes. In the 1960s, new discoveries led geologists to take another look at Wegener's work. However, during Wegener's lifetime, few geologists accepted his theory. Okay, turning the page to page 272. What evidence supports continental drift? So just like anything else, we got to cite our evidence. Wegener provided several kinds of evidence to support his explanation of continental drift. He noted similar fossils and rocks on distant continents. He also pointed out changes in the continent's climates over millions of years. Evidence from the rocks. Rock formations can provide evidence about past events that took place in a particular location. For example, parts of Africa and South America contain rocks of the same age and type. If these continents were once joined, similar rock layers would continue across their borders. Mountain ranges and mineral deposits across today's continents would also line up in the same way. These facts suggest that the continents drifted apart. Other evidence indicates that the continents have also drifted to different climate zones. For example, North America and Antarctica contain coal deposits. Coal is formed from the decaying tropical plants found near the equator. Today, neither North America nor Antarctica lies near the equator. For coal to be found on these continents, North America must have moved north from a tropical region, and Antarctica must have moved south. Evidence from rocks' ages. How can scientists tell which rocks are older? Scientists compare the age of one rock with the age of another to find the rock's relative ages. When two rock layers are found in the same rock formation, normally the lower rock layer is older. Scientists also compare ages of similar rock layers that formed in different areas. Sometimes the types of fossils found in a rock can help scientists determine the age of the rock. Index fossils, fossils of organisms that lived only during a particular time, can help narrow down the age of the rocks in which they were found. Evidence from fossils. Ancient fossils of some extinct animals and plants have been found in parts of Africa, South America, India, Australia, and Antarctica. These fossils include 3 reptiles: Lystrosaurus, Cynothus, and Mesothorus, and a plant, Glossopteris. These organisms would not have been able to travel across an ocean. However, their fossils have been found on continents that are separated by vast oceans today. This suggests that the continents they lived on were once connected. Another bit of fossil evidence supports the hypothesis of continental drift. Fossils of Glossopteris and Lystrosaurus have been found in Antarctica. They could not survive in Antarctica today because it is too cold. This suggests that Antarctica drifted from a warmer region to a colder one. Despite all the evidence, some scientists remain skeptical that the continents were together at one time. All right, we'll stop there. Go ahead and look up at that map, though. You can see how they are showing that fossil records are spread out over these large continents, and their argument is there's no way these animals could have moved from one continent to another unless at some point those continents were connected. Okay. All right, thanks again for watching, and I'll see you on the next one.